Hi class, welcome to lesson 100. We made it to 100. Today's lesson is about estimating square roots and then talking about irrational numbers. Okay, now we've been working with perfect squares for a long time. Okay, so I've listed the list of the first 10 perfect squares up here on the board. Okay, 1 is 1 times 1, 4, 2 times 2, 9, 3 times 3, and on and on and on. Okay, so these are our list of perfect squares. So if they are perfect squares, then when we square root them, we end up with a whole number, a rational number. Okay, so the perfect square of 16, if I square root it with the square root symbol, okay, the square root of 16 is 4 because 4 times 4 makes 16. The square root of 64 is 8 because 8 times 8 makes 64. Okay, but not every number is a perfect square. Okay, so if we go to square root a number that's not a perfect square, we're not going to end up with a nice whole number. Okay, but we can estimate what it's near, what the square root of a number is, based on the perfect squares that are just below it and just above it. Okay, so consider this, the square root of 40. Now 40 is not a perfect square, okay? But 40 is close to some numbers that are perfect squares, okay? 36 is a perfect square that is just below 40, okay? And then 49 is a perfect square that's just above 40. Now the root of 36 is 6, and the square root of 49 is 7. So that means that the square root of 40 is between 6 and 7. It's going to be 6 point something, some decimal number. Okay? Now, and I can tell 40 is closer to 36 than it is to 49, so it's going to be closer to 6 than it is to 7. Okay? But it'll be between 6 and 7. Okay? So think about the square root of 71. Think about the perfect square that is just below that and the perfect square that is just above that. Hopefully you said 64 is just below and 81 is just above. The root of 64 is 8. Root of 81 is 9. Okay, so the square root of 71 is going to be between 8 and 9. Okay, is it closer to 8 or 9? Well, let's look. Is 71 closer to 64 or is it closer to 81? Well, it's closer to 64. So it's going to be closer to 8 than it is 9. It's going to be 8 point something. Some decimal number, okay? So we can estimate the square root of a number that's not a perfect square by thinking about what squares are just below it and just above it and the roots of those, okay? Okay, let's talk about irrational numbers. You need to get this definition in your notebooks. Irrational numbers are numbers that cannot be expressed as the ratio of two integers, okay? So before, when we talked about rational numbers, we said a rational number was a number that could be expressed as a ratio, a fraction of two integers, okay? If it cannot be expressed as the ratio of two integers, we are dealing with an irrational number, okay? Another way to think about irrational numbers is that they turn into non-terminating, I should say terminating, I-N-A-T-I-N-G, non-terminating, non-repeating decimals. Okay, so think about that. If we turn a number into the decimal form and it does not terminate, but it doesn't repeat, then we are dealing with an irrational number. Okay? So if I think about the set of real numbers include rational numbers and irrational numbers. Okay? Now we talk about the set of real numbers because later on in your math careers, when you hit, I think about Algebra 2, you'll start dealing with imaginary numbers that are not included in the set of real numbers. Okay? But for the next couple of years, we're dealing with real numbers, okay? So we're talking about rational and irrational numbers. So I've written some numbers here, okay? So let's use these numbers as a way to talk about what numbers are rational and what numbers are irrational. Okay? Let's think about -3/4. Can this number be expressed as the ratio of two integers? Well, it's already a ratio, right? Is it a ratio of two integers? Yes, integer on top, integer on bottom. So this is a rational number, okay? If I were to turn this into the decimal form, -0.75, it terminates. Okay, so it's considered a rational number. What about radical 3? Radical 3. If you end up trying to find the square root of a number that's not a perfect square, you're going to have an irrational number. Okay, this is going to be a non-terminating, non-repeating decimal. So this one is irrational. I cannot write this as the ratio of two integers. So this one is irrational. This one's rational, irrational. 0.5 repeating. Okay, 0.5 repeating. Could I write that as the ratio of two integers? Well, look at our definition here. It tells us in the definition. Is this a non-terminating, non-repeating decimal? No, actually, it is a repeating decimal. So this is rational. If your decimal repeats, it is a rational number. Okay? What about radical 4? Well, radical 4 is a perfect square. So if I say square root of 4, that is 2. Can 2 be written as the ratio of two integers? Sure. 2/1, or 4/2 is 2, right? Okay. So if I have a number that I'm finding the square root of, and the number inside is a perfect square, it's a rational number. Okay? The last one let's talk about is pi. Let's look at this definition. Does pi terminate as a decimal? No. That's the special thing about pi. It just keeps going on and on. Does it repeat? No. That's another special thing about pi. So guess what? Pi is an irrational number. Okay? Pi is irrational. So now let's think about where these go on the number line. If I'm going to put these different numbers on the number line, where is -3/4 going to go? Well, it's less than 0, but it's not quite to -1, so I'm going to put -3/4 about right here. Okay? Draw this in your notebook and see if you can put the numbers in the correct place on the number line before I get to them. Radical 3. Well, this is where I have to think about what the square root of 3, which two consecutive whole numbers is it between? Well, the perfect square just below that is 1. The perfect square just above it is 4. So it's going to go between 1 and 2, because the square root of 1 is 1, the square root of 4 is 2. So it's going to be between the 1 and the 2 here on my number line. But is it closer to 1 or closer to 2? Well, 1 squared is 1, 2 squared is 4, and 3 is closer to 4 than it is to 1. So I'm going to put it right about here. Radical 3, square root of 3. 0.5 repeating. Well, it's bigger than 0, but less than 1, and just a little bit to the right of half. So I'm going to put it here, 0.5 repeating. Okay? Square root of 4. Well, we already said the square root of 4 is 2. So that goes here. Square root of 4. Okay? Pi. Well, we know that the decimal equivalent is 3.1415, on and on and on. So it's going to go just to the right of the 3. Okay? Okay. So, you need to memorize this definition of what an irrational number is. An irrational number cannot be expressed as the ratio of two integers. It is a non-terminating, non-repeating decimal. Okay? Okay, go ahead and pause your video, do your practice set. There's even a question right above where the practice set starts. Go ahead and start there by answering that question. Okay? And then do A through F on your practice set, and then start your video back up again. Okay, so let's start with the question just above the practice set. Which of these types of decimal numbers are irrational? you should have written non-terminating, non-repeating decimals are irrational. Okay? Okay, A, the square root of 7 is between 2 and 3. Okay? Square root of 7. The perfect square just below it is 4. That has a root of 2. The perfect square just above it is 9. That has a root of 3. So the square root of 7 is somewhere between 2 and 3, closer to 3 than it is to 2. B, the square root of 70 is between 8 and 9. Square root of 70. This perfect square just below it is 64. That has a root of 8. The perfect square just above it is 81. That has a root of 9. It's between 8 and 9, closer to 8. Okay, it's 8 point something. C, square root of 700 is between 26 and 27. Okay, these are some squares that we had in our lesson, our last lesson, 99 on the Pythagorean theorem. Okay, square root of 676 is 26. Square root of 729 is 27. So 700 is between 26 and 27. The square root of it is. Okay, now this is the next couple were interesting. They want us to figure out what x and y were. This is based on our knowledge that we learned yesterday with the Pythagorean theorem, okay? On D, we have to find the length of the hypotenuse. So this leg squared plus this leg squared will give me the hypotenuse squared. Okay? I squared 1, I squared 1, I added them, I got 2. So 2 is equal to x squared. Now to find out what x is, I need to square root both sides. So x is equal to the square root of 2. That's where it stops. Square root of 2. 2 is not a perfect square, so I can't square root it. To have the most exact answer, I leave it radical 2. Okay? The second one here, this is a leg, this is a leg. Here's the hypotenuse. So 1 squared plus y squared is equal to 2 squared. 1 squared is 1, plus y squared is equal to 2 squared is 4. Subtract 1 on both sides. Y squared is equal to 3. I need to square root both sides to get y. Y is equal to the square root of 3. That's the most exact answer I can have. Okay? Last one, F. We had to place these numbers on the number line. The first one was radical 3. Well, radical 3, the square root of 3 is in between 1 and 2. Closer to 2 than it is 3. The next one, 0.3 repeating, 0.33333. Between 0 and 1, it's less than half, so I'm going to put it closer to the 0 than the 1. Pi, 3.14, should be just to the right of the 3. Negative 1/3, okay, when I think about that as a decimal, it's negative 0.33333, negative 0.3 repeating, so that's just to the left of the 0. Okay? Okay, I hope you did well today. I hope you guys have a great day, and I'll see you next time. Bye.